Hi, welcome. Thanks for watching. The purpose of this video is to walk through this sort of problem in which we need to quantify the equilibrium constant, or Kc. I'm going to start by just setting up the Kc expression. Kc is equal to the concentration of the products, in this case IBr, to the power of their coefficient, in this case 2, over the concentration of the reactants, in this case iodine to the power of 1, and bromine to the power of 1. So I'm not going to write the ones. I notice that everything's in the gas phase. It is homogeneous, so I'm good to use the Kc expression. All right, I now see I'm given some initial concentrations and equilibrium concentrations. The equilibrium concentrations are the ones that we're looking at Kc. And so if I can just find X, well, then I'll have concentrations at equilibrium, and I can plug them into my Kc expression. All right, so how do I find X? Well, I'm going to start by picturing the chemistry that's actually happening. So I have my reaction container, and it looks like I start by only adding reactants, only I2 and Br2. As soon as I have some I2 and Br2 in there, some of the I2 and Br2 is going to react to form IBr. And we're going to make a bunch of product. Now, this reaction is reversible. It's in equilibrium, which I know based on that symbol. So my IBr is going to react and do the reverse reaction to remake I2 and Br2. So I'm going to get a big mixture in here of I2, Br2, and IBr, all going back and forth. Once I reach the point that the amount of IBr and the amount of I2 and Br stop changing, that's when I'm at equilibrium, and that's what I'm trying to quantify with Kc. I'm trying to figure out for this reaction at this temperature, what does the equilibrium look like? At equilibrium, do I have mostly products? Do I have mostly reactants? Do I end up with a mixture of the two? That's what I'm trying to quantify with Kc. All right, so I have some numbers here, and I need to figure out how to find the concentration of IBr of the product, at equilibrium. So these are all concentrations. However, let's just assume that I have 1 decimeter cubed of reaction, that's my total volume. Because I have concentrations, it really doesn't matter what volume you use. You could use 0.5 decimeters cubed and then figure out how many moles you actually have. But why use 0.5 decimeters cubed when if I use 1 decimeter cubed, well then, if my concentration is 0.2 moles for every decimeter cubed, if I have 1 decimeter cubed, then I just have 0.2 moles. So, because they're concentrations, it doesn't really matter what volume I think about. I'm going to think about it in terms of 1 decimeter cubed, because that means I can just think of these numbers in terms of moles. All right, all of a sudden, this becomes a pretty easy problem. I see that when I do the reaction, I start with this many moles of I2. I end with this many moles of I2. That means 0.1 moles of I2 reacted, and I need to find out how much IBr that made. Well, that sounds like just a limiting reactants problem. Just go back to my good old friend stoichiometry. So if I have 0.1 moles of I2, how much IBr did I make? Well, let's just use those molar ratios. 1 mole I2, 2 moles Br, which I'm getting from the coefficients. I made 0.2 moles of, this should be IBr, of IBr. I should check the other reactant to see if one of them was limiting. I see here I also used 0.1 moles. So I'm going to use those same molar ratios. And I again get 2.2 moles of IBr. That tells me that I2 and Br2 were, neither was limiting, neither was in excess. They reacted completely to make 0.2 moles of IBr. Again, I was assuming that my volume was 1 decimeter cubed, so 0.2 moles over 1 decimeter cubed of IBR. That's the concentration of IBR at equilibrium. All right, beautiful. Now that I've solved for X, I can just plug in my numbers into my formula here. So Kc is going to be equal to concentration of IBR is 0.2 squared, and concentration of I2 is 0.1. Concentration of BR2 is also 0.1. And now I just have a little bit of mental math to do. This is a paper 1 problem, so of course there's no calculator. So I just need to think through the mental math. So 0.2 squared would give me 0.04. 0.1 squared would give me 0.01. There's a few ways you could think about this problem. I kind of like when I have decimals to just put everything in terms of fractions, because for me that's a little bit easier to see. Maybe you have a better way to do it or a way that works better for you, but for me this makes a lot of sense because now, okay, well I see I'm dividing by a fraction. That's the same as multiplying by the reciprocal. So I have 4 over 100 times 100 over 1. I see my 100s cancel, and I end up with 4, or C. You could have also, in this case, multiplied the top and bottom by 100 to get 4 over 1. Oops, sorry about that. To get 4 over 1, and you would also end up with C. All right, thanks again for watching. I hope that helped. Have a good day.